So here's a question. We again have been given the same fx as mod of x, right? We need to
Yes.
find what is the function doing at what point. So let's again, now that we are comfortable with this graph, we'll directly draw it and check for itself. Is the differentiation at 0 equal to 0? No, it's not defined. There's a sharp turn. Whenever there's a sharp turn in any of the function, the differentiation is not defined. So this option is invalid. Fx has a maximum at x is equal to 0. Obviously not, we can see that it is the minimum actually. So of course it has a minimum at x is equal to 0. This is correct. This is incorrect. Any doubts here? Just by observing the graph, you could have identified this.
So let's say if I couldn't think of the graph at that point, how can we solve this then?
Very good question. So understand, in order to find the maximas and minimas, we need to identify three things, actually a couple of things. Wherever f dash x is equal to 0, identify those points. These
Yeah.
points are called as stationary points. Also, wherever f dash x is not defined, because those could also be potential points for maximas and minimas. Check for them as well, right?
Yeah.
For most of the cases, because the function will be continuous and differentiable, you wouldn't have to check this one. But for questions which involve mod symbols, these kinds of questions have sharp turns. So it's better to identify those points as well where the definition is changing. Even for a function like, let's say I am defining x minus 1 for x greater than 0 and uh, x plus 1 for x less than 0. These are my definitions. So do you see that the definition has changed at x is equal to 0? At x is equal to 0, the definition has changed. So the graph might have a breaking point or a sharp turn at those particular points where the definitions are changing, all right? Or where the mod graphs are involved, check for those points. Because minima and maximas does not mean that the differentiation has to be 0 at that point. There can be, the differentiation cannot be defined also. That could also be the case, right?
Yeah.
So you have to check for that as well. And you would basically know the definition of the function, like I said, x and minus x for greater than 0 and for less than 0. So you can check at x is equal to 0, from the positive side the differentiation is 1, from the negative side the differentiation is negative 1. If the LHD is not matching the RHD, which means the function is not derivable at the point x is equal to 0. Agreed?
Yeah.
At the same time, the moment you have established that it is not derivable, but is it continuous? Yes, it is continuous, because in the function, if I'm putting x as 0 from the left hand side or from the right hand side, the answer is coming out to be 0, which means it is a continuous function. Oh, so at the point where the function is not derivable, yet it is continuous, let's check. Let's check whether it is the minimum point or not. So how to do that? Towards the right hand side, the differentiation is positive, and towards the left hand side, the differentiation is negative. Oh, which means the sign of the differentiation has changed from negative to positive, which means it must be a point of minimum. Any doubts?
No.